It's the Milky Way as you've never seen it before. 2.5 billion infrared pixels are exposing our own galaxy in this new image from NASA's Spitzer Space Telescope.
The Hidden Universe Showcase explores exciting new results in infrared astronomy from NASA's Spitzer Space Telescope, with your host, Dr. Robert Hurt.
Science is all about getting the big picture, but some pictures are definitely bigger than others. You may have used your computer to make a large panorama yourself by stitching together a few shots from your camera. Depending on the camera, the final picture may contain 10 or 20 million pixels. Now, can you imagine taking over 800,000 pictures and combining them into a single 2.5 billion pixel image? Two teams of astronomers have not only imagined it, they've used NASA's Spitzer Space Telescope to make one. And it's online for everyone to explore. Over 50 astronomers have worked on this massive project since the Spitzer mission began. This image combines data from two different legacy projects, known as GLIMPS, headed up by Dr. Ed Churchwell, and MIPSCAL, led by Dr. Sean Carey. The picture covers an area of sky about as wide as your finger, held out at arm's length, and as long as your open arms. Though it sounds like a pretty small slice of the sky, it actually captures half of our entire galaxy. Our sun sits a ways out from the galactic center, so a 130-degree arc takes in most of its area. So our Milky Way is actually very thin compared to its diameter, a lot like a CD. So even a 2-degree wide scan is going to include most of its disk. The rest of the stars that fill our sky are actually very, very close to us, filling just a tiny fraction of the disk right around our sun. A space image this big takes a lot of space to show off. Spitzer unveiled this giant banner, 4 feet tall and 180 feet long, at the 2008 summer meeting of the American Astronomical Society in St. Louis. Since then, it's been on display at the Adler Planetarium in Chicago and at the Griffith Observatory in Los Angeles. The GLIMPS part of the survey includes the shorter infrared wavelengths. At 3.6 and 4.5 microns, we see blue stars that, in visible light, are completely hidden by dust. Carbon-based dust molecules show up at 8 microns, represented as green. MIPSCAL contributes the 24-micron component, rendered as red. This is the warm thermal glow from dust clouds heated by nearby stars. Together, these observations give us a pretty complete view of stellar evolution, beginning to end, across our galaxy. These ubiquitous dark filaments are dust clouds, so dense they're opaque even in the infrared. They're dense enough to trigger gravitational collapse and form new stars. The red dots seen along these filaments are embedded protostars, only barely seen, the longest and most transparent infrared wavelengths. Once the stars are fully formed and glowing from the heat of nuclear fusion, they illuminate, warm, and disrupt the surrounding dust, creating these dramatic structures. The stars eventually drift beyond their birthplaces, mixing among their older cousins. This diffuse blue glow shows us the overall distribution of stars throughout the galaxy. Eventually, the most massive stars die in supernova explosions. We can see their expanding shock waves, rich in newly forged heavy elements, that will help form the next generation of dust and stars. The GLIMPS MIPSCAL survey is truly a pictorial guide to the past, present, and future of stars in our home galaxy. Astronomers will study the data for many years to come, and the observations will be a roadmap to guide future infrared observatories. If you'd like to explore Spitzer's Milky Way, all 2.5 billion pixels are available on our website. You can download the whole thing in segments, or use one of several web viewers that let you pan and zoom through the image interactively. Take a look. You might find something that no one else has seen. For the Spitzer Science Center, I'm Dr. Robert Hurd, reminding you there's a hidden universe just waiting for you to explore.
The Hidden Universe is produced by the Spitzer Science Center at the California Institute of Technology in Pasadena. The Spitzer mission is managed by NASA's Jet Propulsion Laboratory.